let me give you the answers to that assignment, and then we'll see if you want me to show you the solutions to any of those. There are 8 of them, right? Okay. These are the final answers to all 8 of those questions. So if you want to go ahead and check those final answers to all 8, and then if you want me to show you how to get those, let me know. No, those aren't the final and only answers with correct statements. So if you don't have exactly those answers, it would be marked wrong. Gentlemen. All right. Do you want to go over anything? Okay. Number 4. All right. So in number 4, you should have circled the positive 15 meters per second, the positive 25 meters per second, and the positive 125 meters. We're asking you for how long, underlined how long. So that means this is your VI, your initial velocity, positive 15 meters per second. You're being told the final velocity, positive 25 meters per second. And you're also being told the displacement, positive 125 meters. So if you put the arrows over these, that's fine too. When we ask you how long something takes, that means we're looking for time. Now, there is no acceleration given, which means there's only one equation that you have on your reference table that enables you to solve this. There's no A. So when you look at your reference table, the only equation that doesn't have an A in it is this one. The V bar equals D over T. We need to solve it for T, so you do the algebraic manipulation next, which gives you T is D over the V bar. Now, you don't have V bar, but you should know how to get an average of 2 numbers. You add them up and divide by 2. So the average velocity is positive 20 meters per second, keeping the precision. So that would be positive 125 meters over the positive 20 meters per second, giving you a time of 6.3 seconds. And then you do your dimensional analysis on T equals D over V bar. So that's meters over meters per second, which is the same as meters times seconds over meters. The meters cancel, leaving you with seconds, which is the unit of time, which is what we want. Okay. Does that make sense? Okay. Anything else? Yep, Khalees. Number 8. All right. In number 8, you should have circled the word stops, positive 484 meters, and negative 8.0 meter per second squared. I'm asking you, how fast was it moving before braking? How fast before? How fast before? So that means when we tell you something stops, that means its final velocity is 0 meters per second. The meters tells me that's a displacement. I'm going to just put the arrows back over these because those are vectors. And this in meter per second squared is an acceleration. So I have the VF, the D, and the A. When I say how fast before, that means I'm looking for the VI. So the equation to use on your reference table, which involves all 4 of those variables, is VF squared is VI squared plus 2AD. Now you have to move it around algebraically to solve for VI, which gives you the square root of VF squared minus 2AD. So I'm going to go ahead and plug in. So that's the square root of 0 meters per second, that amount squared, minus 2 times negative 8.0 meter per second squared times positive 484 meters. You take the square root of that, and that gives you 88 meters per second. Now it just says how fast was it moving, which means I'm looking for a speed. So actually this should not have an arrow over it. I'm just looking for the speed, not its velocity. I don't care about the direction. That's why I don't need to worry whether it's positive or negative. It's just 88 meters per second. Now, how do we do our, well, you weren't asked to do the dimensional analysis on number 8. You were only asked to do it on 1 through 4. So I'm not even going to go over how to do that unless someone wants me to do that. Make sense, please? Which equation? The manipulated one? Okay. So if the equation that you're given is VF squared equals VI squared plus 2AD, and you want to isolate VI, the first thing we do is subtract the 2AD from both sides. That's one entire term. So that gives us VF squared minus 2AD is VI squared. Now you got to undo the square. So you take the square root of both sides. So that gives us VI is the square root of VF squared minus 2AD. Okay. Miriam? Number 6. Okay, you should have circled starting from rest, positive 110 meters and 5.0 seconds. Should have underlined the word acceleration. So when we say that you start from rest, that means your initial speed or your initial velocity is 0 meters per second. This is a displacement, and that is a time. We are looking for the acceleration. So we start with the equation that involves VI, dt, and A from our reference table, which is D is VIT plus half AT squared. I'm going to get rid of the VIT. That's going to drop out because the VI is 0. 0 times anything is 0, which leaves me with an equation of D is half AT squared. That's easier to manipulate for the A, which means I'm going to multiply both sides by 2 and divide both sides by T squared, or you could divide by half T squared. That gives me A is 2 times positive 110 meters over 5.0 seconds, which must get squared, giving me an acceleration of positive 8.8 meter per second squared. And since acceleration is a vector, I do need to put the positive sign on that answer. Does that make sense? Yep.
Would you be marked wrong if you put that arrow over the D?
No. Nope.
Oh, so that'll be okay.
Yep.
Okay.
Anything else? Yep. Roger.
Go for number 3.
Yep. All right, you should have circled positive 88 meters per second, positive 132 meters per second, and 15 seconds. You should have underlined the word displacement. So I'm giving you the VI, the VF, and the T. This is our initial velocity, positive 88 meters per second. This is the ending velocity, positive 132 meters per second, and I'm giving you the time. I'm looking for displacement. So that means I need an equation that does not include A. There is only one equation on your reference table that does not have A in it for kinematics. That is the V bar is D over T. So that means the displacement is the time times the average velocity. Now, how do you get the average of two velocities? You add them up and divide by 2. And whenever we do an average, we keep the precision of the measurements. These are both to the ones place. So the 0 in the ones place has to be a significant digit, which means we add a point after it. So that is 15 seconds times the positive 110 meters per second. I'm going to round to 2 sig figs, which gives me a displacement of positive 1,700 meters. So now I do my dimensional analysis on does D equal T times V bar. So time is seconds. V bar is in meters per second. The seconds cancel, leaving me with meters, which is what I expect. Okay? Anything else? All right, then let's take our quiz. You can keep out that homework. You can keep out your reference table. You will need your reference table and your calculator. I'm going to give you a quiz to solve. Just make sure you follow the directions at the top of the quiz. You can use your homework to help you. Good luck. Just make sure you follow the directions at the top of the quiz, please. This is an 8-point quiz. Well,